In this final video, we're going to take a look at how we can use Descartes' rule of signs to be able to determine the number of possible negative zeros, the number of possible positive zeros, and then also the number of complex zeros given a polynomial function. All right. And really, all we're going to do is we're going to go ahead and find the number of sign changes of f at x. We're also going to find the number of sign changes of f at negative x. And then however many sign changes there are either that many positive or negative zeros, or it's going to differ by a positive even integer. So we're going to subtract 2, subtract 4, subtract 6, etc., until we don't have a negative number. Okay, so it's actually pretty easy to do this, but we just keep subtracting 2 each time until we get to a negative number for the number of possible zeros. And then remember, we take a look at the degree of the polynomial. And so this tells us how many possible zeros there are total. Okay, so of course, we can always check this by graphing, which we will at the end. So let me show you a few examples of this. Okay, it's not too difficult. So we have this x cubed plus 2x squared minus 5x minus 6. All right. And also what I'm going to do is let me find f at negative x. And what f at negative x is going to do is any term that has an odd exponent is just going to change signs. So that's going to be negative x cubed, which we've probably figured out already, plus 2x squared minus 5x minus 6. All right. Now, we're going to take a look at the number of sign changes. Okay. So a sign change basically means from positive to negative. Okay. So there's no sign change here. There is a sign change here, but there's no sign change here. Okay. So basically it goes positive, positive, negative, positive, or negative, negative, excuse me. And that means that there's one sign change. Okay. So for this means there's one sign change. And what that means is that there is one positive or one possible positive. Let me rewrite that. So one possible positive zero. Okay. Now over here, okay, negative to positive, so that's 1. Back to negative, that's 2. And then this stays. Okay. So there are 2 sign changes. And so what that means is that there are either 2 possible negative zeros, or there are 0 possible negative zeros. Okay. And that's just because we subtract 2. Okay. So each time, remember, we said that the sign changes by a positive even integer. Okay. So each time, if we can subtract 2, we do. Now over here, if we subtracted 2, that would be negative 1, and that doesn't make any sense. All right. Now, one other thing to remember is that the degree is 3. Okay. So there are 3 total zeros. Okay. So here's what we can do to be able to find out what the possible combinations of zeros might be. Okay. So I'm going to make like a small chart here. Okay. So we have our positive zeros. Then we have our negative zeros. Okay. Then we can have our real zeros. And these are possible numbers. And then we have our complex zeros. Okay. So remember, for positive zeros, there's one possible zero no matter what. For the negative zeros, there's either 2 or 0 of these. And so what that means is if I add these together, that should give us the number of possible real zeros. Okay, so that would be either 3 or 1. Now, the complex solutions is going to be n minus the number of real solutions. And so remember, n was 3. And so this would be 3 minus 3, or 0. And this total should be 3. Okay, so basically we could say that there are either 3 real zeros and no complex zeros, or 1 real zero and 3 minus 2, 1 is going to give us 2. Okay, so those are the possibilities for this. Now, of course, let's just graph the function and see whether we have 3 real zeros or 1 real zero. Okay, so we go back up here, and the function was x cubed, 2x squared, 5x minus 6. So we have x cubed, 2x squared, minus 5x minus 6. All right, and it looks like that we have 2 negative zeros, 1 positive 0. Okay, and so if we go back to our chart, that was one of the possibilities. We had 1 positive and 2 negative zeros. Okay, but again, that's what Descartes' rule of signs does. It tells us the number of possible real zeros and the possible number of complex zeros. Okay, all right, so a couple more examples of this. So we have our x cubed plus 7x squared plus 11x minus 3. Right? And so again, let's find g at negative x to start. And so that just changes all the odd exponent terms. So we have negative x cubed plus 7x squared minus 11x minus 3. All right, so here's our possibilities. Okay, so we go through here. We know we have positive, 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 and then a negative. So there's one sign change. So that means that there's one possible positive 0. Okay. And that's it. So right away, we know there's going to be one positive 0. Okay. Over here, we have negative to positive, so that's 1. Here's 2, and this one stays negative. So we could either have 2 possible negative zeros or 0 possible negative. And then we just make our chart just like we did before. Okay. The degree was 3, so that's important. Okay, so right here we see the degree of the polynomial is 3. And so we have our possible positive. We have our possible negative. Okay. And remember, there's always one, okay, possible. And then there's either 2 or 0. The number of real is just going to be these sum. Okay, so that's going to be 3 or 1. And then for the complex, it's going to be n minus real. Okay, so in this case, it would be 3 minus 3 or 0. So there's either 3 real and 0 complex, or 3 minus 1 is 2, okay, which means that there is 1 real and 2 complex. All right, now, once again, let's graph it. Let's see what happens. So we have our x cubed, and I think it was 7x squared, 11x. So we have a 7x squared, and then we have 11x, and then I think we had minus 2. Let me check that just to make sure, minus 3. All right, and so what it looks like is that we have 2 negative real zeros and 1 positive real 0. Okay, that's okay, no problem. Okay, so just showing you that the rule of Descartes' rule of signs just tells us the possible number. Okay, now one last example. Let's have a 4th degree polynomial. Right? And once again, let's find h at negative x, and the only sign that's going to change is going to be 5x because it's the only one with odd degree. So x to the 4th, 6x squared plus 5x minus 2. Over here, we notice that there's one sign change. Okay, so that means from here to here, there's one sign change, and then the rest of them are negative. There's going to be one possible positive. Over here, we have one sign change, 2 sign change, 3 sign change. And so there's 2 outcomes that could happen. We could have 3 possible negative zeros. So 3 possible negative, or if we subtract 2, 1 possible negative 0. Okay, and so from our chart, there's 2 outcomes that could occur. So we have our possible positives, we have our possible negatives. So possible positive is 1, and then we have 3 and 1. N is equal to 4. Okay, and so what that would mean is that there are either 4 or 2 real zeros. Okay? And then the other possibility is that for the complex zeros, remember that's going to be n minus the real. That's going to be 4 minus 4, which is 0. Okay, so there's 4 reals at 0 complex, or 4 minus 2 is 2. Okay, and so what that means for us is that there's either 4 reals, 3 positive, 1 negative, or 2 reals, 2 complex, and then finally, we would have 1 positive, 1 negative. Okay, now let's go to the graph and see what that says. Okay, so we have x to the fourth, and then we have minus 6x squared minus 5x minus 2. All right, now check this out. Just making sure I type this in, x to the fourth minus 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 652. Okay. We have 1 negative 0. That's real because it passes the axis. We have 1 positive 0. That's real. But then we have 2 complex. Okay. So the total number is going to be 1 positive, 1 negative. And if you go down here, check that out. We have 1 positive, 1 negative. So 2 real roots and then 2 complex roots. Okay. Because it doesn't cross the axis 4 times. Okay. If it crossed the axis 4 times, there would be 4 possible roots or 4 positive or negative roots that are real. Okay, so that's how we can use Descartes' rule of signs. Okay, it's not meant to be too difficult, just helping you to see the possible number. Okay, so this is everything that we're going to talk about with respect to our the zeros of polynomial functions. We're going to move away from polynomial functions in our next couple videos, and we're going to take a look at rational sort of functions in the next video. And then in the final video in the unit, we're going to take a look at the inequalities of both polynomial as well as rational sorts of inequalities.